record. Wait for the robot voice to finish. Okay. Hello, everybody. Welcome to an AMA on the wind down of Qri. My name is Brendan, and I'm just going to use this time to answer some questions. And as Casey's put a wonderful prompt, talk a little bit about sort of why Qri got started in the beginning and where we ended up, and ideally answer any questions that go from there. As a format, if you just pop a question into chat as it's going, I'll read the question out and then try to answer it out loud. If I think that particularly with the technical stuff, if we have technical questions, I'm happy to field them. I might divert them to a different forum to answer them, because answering technical things at length can sometimes be can take a minute and can take up a lot of time. But yeah, to start off with the prompts, Qri got started. The company was founded in 2016. In particular, so for a little bit of background, I'm Canadian and witnessed what I thought was some like not so great practices on the part of the Canadian government back in 2008 and 2009 around access to scientific research and knowledge dissemination. In Canada, we had the term libricide both coined and popularized to describe the Harper administration's attitude towards suppression of knowledge. And so we're not a big fan of that. And in 2016, in the US, the Trump administration incoming there was a bit of concern amongst a number of folks that the access to, in particular, the EPA.gov sort of data set and the total data posted on EPA.gov might be turned off. We realized that might not be a good thing. And so a number of us tried to work to archive large swaths of government websites to make sure that that data remained available. And in doing that, we uncovered a pretty thorny problem, which was when it comes to building and synchronizing both moving a bunch of data to back it up and then also securing a degree of provenance to prove that the thing that you moved didn't change in flight and could be trusted later, was a really interesting problem to work on with a very immediate use case, at least to a number of us at the time. And so we started Qri, the company, in an effort to build an open source tool to help facilitate stuff like that, where people could build and maintain data catalogs that had many contributors, not just sort of a single set of folks with right access. It was very much where the project got started. And that was one of the many reasons that we sort of tried to found the whole tooling and infrastructure on distributed and decentralized techniques, specifically IPFS. Hopefully that gives a little bit of background for the project. Project lasted for 5 years. We're now currently figuring out what to do with it next, including switching to a community maintenance mode or some other permutation. But as far as building a business model around the company, we did not succeed in sort of creating a business model we thought would sustain the project long term. So that's kind of where we're at right now. And then we have this first question, which basically says, the question reads from Case, when you look back at the original goal of enabling peer-to-peer data set sharing and hosting, how did the choice for IPFS work out? What would you choose if you would implement a stack today? Phenomenal question. The short answer is the choice of IPFS did not work out. There are two high-level goals that I alluded to in the sort of winding down Qri posts that I made, I made with the help of everybody on the team. The first was that data isn't code, which is a long-winded way of talking about product market fit and a lot of things that I learned as somebody who founded a company around a problem that wasn't principally mine. But the second was really about the challenges of iterating on any of the decentralized sort of stack of tooling when your competitors are in a Web 2 setting. And so a lot of the other folks in the market are using centralized tooling for building and managing data catalogs. And so the choice to use IPFS in practice really slowed down our capacity to ship features. And over the course of 5 years, that slowness, just to give you the most concrete example, from the first day of building Qri, we had users asking for private data, for the capacity to encrypt their data sets and move them around with a shared trusted group of people. In a centralized setting, that is actually quite straightforward to ship, and a number of folks in the space just ship that as default as part of their initial product offering. 5 years on, we actually couldn't solve that problem. So to give you a sense of like the time that is involved, that like that's just not, that wasn't there. And a lot of that had to do with the fact that we were trying to maintain protocol level compatibility with IPFS. And so there are lots of techniques for just encrypting data and put it on IPFS, but we wanted to sort of maintain a high degree of parity with the technology itself because we wanted to be good citizens of the new web. And so to answer the second question, the second part of the question is, what would you choose if you were to implement the stack today? If I were to redo it all, I would not make any promises of compatibility with any distributed protocol. I would instead just make a series of breaking changes and say, we're going to get this to work, and then we're going to figure out some translation mechanism that would allow us to effectively backport onto something like IPFS. Very similar to the way that like it would be possible to make Git interoperate with IPFS. A number of people have tried. And there's like a pretty clear path to doing that. But one of the biggest challenges you run into is iterating on top of protocols is really hard. And we needed a number of changes that just were very, very difficult to do and also maintain. One like actual low-level compatibility with IPFS. Next question. Sorry, go ahead if you want to follow up, Case.
Yeah, I just wanted to follow up because I think you sort of gave two answers about business model and then also about making it really work with IPFS, which took a lot of time. But is it I can understand from a company perspective and a business model that you need paying customers, and then comparing sort of data sharing or data hosting solutions, you're going to be, of course, at a big disadvantage. But isn't the idea or the promise of using decentralized technology in the first place? I mean, is it the right market to be selling that to companies? I think it's a use case of its own, right? Where you want people to be able to rehost EPA data sets. I think that's a great example. And of course, that would, if you really want to have a promise where no one can take it down, right? As long as there's one copy, someone can host it, and there's the protocol, so another person can come in and then still access their data set. That requires a truly decentralized setup. So isn't something like IPFS the only choice there? I mean, I understand the comparison with Web2 technology, but I'm more interested in how would you do it in a truly decentralized way?
I see. So like holding for the quality of decentralizability. The short answer is no, IPFS is not the only solution by any stretch of the imagination. Like BitTorrent has been around for a long time and does provide a lot of the same decentralization characteristics as does the Hypercore protocol, which would have been another, which when I started it was called DAT, which is another actually quite lovely peer-to-peer system. There's also just like hand rolling, like content addressability is not solely the domain of IPFS when it comes to if you wanted to solve for preserving the untakedownable approach. So there are a suite of alternatives. If that's the constraint of maintaining a decentralization characteristic, I think IPFS is a pretty good choice amongst those technologies. Like personally, if I had to redo it again and the constraint was it must be a popular decentralized protocol, I'd probably still pick IPFS. I think it's the farthest along. And for us, one of the most important things when you think about a data catalog is really the sort of single swarm behavior of IPFS. And that's just the idea that in BitTorrent, you would have each one of them being a different magnet. And that's like there's like a huge coordination problem at that point. Yeah, so does that help answer the question that you had, Race?
Yeah, definitely. Yeah. I mean, I saw some other follow-up questions too, so I don't want to get in the way.
Yeah, perfect. Thank you. If you don't mind, I'd love to move on to some other ones, but feel free to follow up in chat if you have others. The next question. Regarding IPFS slowing things down, do you see it mainly as having been a hard technical environment to work in, or was the pull to participate in a deeper level in IPFS or protocols, etc. Also distraction from focus on queries goals. Are those even things that you can distinguish between? So this is like, the way that I'd frame this is the question of like, how much of your time goes into like upstream participation, because we are a downstream, our software actually depends on IPFS, the library, and the community around IPFS and the technologies itself. The word distraction is the thing that I would key on the most there. I have not had enough time away from everything to sort of figure out whether or not it was a distraction or whether it was actually in support of our goals, because our stated goal was really to achieve some level of decentralization, and that really is shared amongst work on IPFS and work on Qri. But to the point of the question of being a hard technical environment to work in, I think that's the thing that I would choose to still focus on, is like this decentralization hill is incredibly steep. We have a lot of very, very, very practical problems that need to be solved that end up being really tough for end use cases, like for users of a product specifically, like just having the expectation of being able to get data fast and cheap and easy. And in that context, if we're speaking purely from what we did from a practical standpoint, if you look at the course of the things from the universe of IPFS that Qri used over time, it went down over time. We would slowly but surely take more things out of the stack and hand roll our own thing and use that instead. And that was a pretty consistent pattern that we saw a lot of the time. We then tried to turn around and upstream some of those things into contributions, and that we didn't, I personally don't feel like I put enough energy into making that happen. But that is where, as somebody trying to build business, that does kind of technically fall under the guise of distraction, because until we had like real revenue and like a scalable model that would match, it's really hard to justify focusing on anything other than growing the project. Hopefully that answers the question. Does that? Cool. I'm taking that. From Christian, can you explain what areas of the business model you attempted to monetize and parts that worked and didn't work? Phenomenal question. And then I'll answer the second one. But the first question, for us, the business model was always, the goals were always such that step one, make an open source tool that is free to use and really powerful, like put all of the batteries in that thing, make it as full features as possible, and put a lot of value into the world. So make it so that a lot of people are using this free and open thing. Step two was to carve out a piece of that, create some convenience inside of that ecosystem, and monetize that. And so for us, what was the reason, I alluded to the note that into the wind down note, that we didn't discover the kind of business that we wanted to build. In order for it to work, we really needed a lot of users, like a lot of users using it for free. And this is where the decentralization IPFS layer was going to help us reduce the operating costs of that big network, so that that thing could actually be, we could say free and mean it. And then the products and services we could ship on top of that all come from the convenience of, I don't actually want to run my own IPFS node. I don't want to go to the trouble of this. I just want to do this in the cloud. And so we could charge you to run IPFS in the cloud if you so desire. For us, that was a justifiable business model that also gave the end user a very clear understanding of when and where they were running into our paywall, as it were, and they could decide for themselves whether or not that fit their use case. For us, practically, it always meant that, and I always sort of said that, like, it would be really important for me for somebody in college to be able to just like spin this up for free and like run an IPFS remote sitting in their dorm room and not have to pay anybody. And for me, that was like a great way to both build a business and have something that like can benefit the world without needing to be so tied up in, whether or not you're part of our ecosystem type thing. It didn't. So the biggest challenge was just we needed super high user adoption for that to work. We would need a lot of people using Qri and relying on Qri all the time, and that would mean like very hockey stick like growth. And we didn't really achieve that. That's sort of that's the part that didn't work, is the top line. You just need a lot of people using it so that you can then take a section of them and create a sustainable business around that. And so that was where we didn't achieve that explosive growth that we needed to make the whole theory kind of hold together.
Thank you.
And then for the second question, does that help answer the question?
Yeah,
You
that
want
was
to
really
clarify
helpful.
that?
Thank you. Yeah, I appreciate that.
Cool. Yeah, we did find some ways to make money in the enterprise space, and there were folks who wanted to pay us in the enterprise space, and a lot of people who wanted like private data, but that's the business we didn't really want to develop. And then I think this helps set up the second question, which is, can you touch on some of the work on encryption that you learned and possible solutions that you're looking toward in the future? One of the projects that we're the most excited about, we did end up coming in direct contact with the encryption question, particularly in the last year of work. We are still, a number of us are still actively collaborating with the folks at a company called Fission with their tool called the Web Native File System, which provides encryption at rest. And in my mind, we actually have a video on our YouTube channel talking about our Go implementation of WinFS and why we think it's a really exciting encryption solution. And can you touch learn and possible solutions? So that's really the solution we're excited about. There's a bunch of like specific problems in there that I don't want to like spend too much time on, but like encryption is a really interesting thing. It has a lot of really interesting implications, but we are continuing to work on the Web Native File System. A number of us are, and I think that that'll ideally, it will make some sort of great encryption primitive that other projects can use, or maybe the community version of Qri could make use of. Christian, does that answer your question?
Yeah, that's great. Thank you.
Yeah, I can put a link, but there's in the Fission paper, the technology isn't yet finished, but it's in a point now where like we really understand the outline of the problem and like have a working prototype that we're hoping to develop into something performant.
It's exciting.
Yeah, I think so too. Timothy asks, regarding advocating for upstream changes to IPFS, if core changes were to be advocated for with the IPFS protocol to decrease friction for projects like yours in the future, what would you suggest those changes be? Advocated for to decrease. Okay, the top one for me would be encryption at rest. Just like baseline support for private data. For me, that's like the most important thing that I think we need. If that was just part of the IPFS protocol, it would be it would open up a category of use cases that would make a lot of things a lot easier. Decreasing friction, and this is where I think the real challenge is like, if you're sitting from the IPFS protocol maintainer perspective, it's really hard to balance all of the use cases that are coming at you. And that's where this, like really the other change I would really advocate for is just a lot of work on understanding the overlapping use cases of all of the different projects you try and utilize IPFS, and doing more work to catalog and understand where they do and don't overlap. There's a really big open question of like, should an access control layer be built into IPFS? Like, should we actually have some mechanism for saying which IPFS peers can and can't access specific kinds of data? But then that gets really thick and thorny, and there are a number of other projects that are working on identity and like the decentralized identifier space, and like there's a whole bunch of stuff there. And so there's a real challenge to know where the boundaries should be. And in my mind, those boundaries really should be driven by practical concerns. Like, how do people achieve the degree of velocity they need to iterate on top of this stack such that they can get where they need to go, so the companies can actually be successful using these technologies. And from that, like the last bit I would advocate for out of that is just like a fundamental refocus on performance. Like, I think that, for us, our experience was we had to turn off a number of things inside of IPFS just because it used a lot of machine resources. There are points where Go IPFS would consume 100% of your processor, or a dramatically high number of the ports that would hurt routers, and like 2 megabytes of RAM per libp2p peer connection. Like, these things like really ended up becoming a concern for us. And so like just figuring out taking on the really difficult challenge of dropping the actual overhead and footprint of IPFS would be a really, that benefit just categorically helps everybody. and so like anything we can get there would be awesome. Timothy, does that answer your question? Cool. I've hit the end of the stack. Do anybody have follow-ups that they want to ask, or something they want to share in real time?
I guess maybe can you maybe talk about some of your opinions on kind of using like a solution like Arweave and like kind of how you kind of view them and like kind of anything they're doing?
Arweave in particular. Yeah, I have to admit to not knowing nearly enough about Arweave for the number of times I have been told to look at Arweave. And that's so like I can't actually speak with a high degree of confidence. If I understand from the like rough outline, Arweave is really based on proof of data availability. And like it's another storage provider, L1 chain. Is that correct, Christian?
I believe so. They're like kind of like where it's like you kind of purchase your data like upfront, and then you can guarantee it's always there, as opposed to like IPFS where it's just like sometimes it's there, sometimes it's not.
Yeah, and so I can't answer your question directly, so I can speak to the data availability problem, which is really what we talk about when we're talking about like one of the chief criticisms many folks will level at IPFS is like, well, if nobody agrees to host the data, then it's effectively gone and effectively useless. And the data availability problem is like, and I call this the data availability problem, which is just like, how do you incentivize some set of folks to actually do the work of making sure the content is available, right? And so I'm more familiar with Filecoin and its incentive network and its effort to sort of to solve that. So I can't speak directly to Arweave, but like I can speak more broadly to the data availability problem.
No, that was actually helpful.
I think
the way you phrased that, like the incentivizing that, like how do you incentivize them to just make sure it's there? And like that's like kind of base level. Now that's like a good way of thinking about it.
Yeah, and like it's a service definition, right? Like that is a service. That is something where there is an exchange of value happening, and a number of folks are trying to approach that from a number of different directions. This and it's questioning it's questioning a thing that is really assumed in the Web 2 space, where look, the data availability problem is solved by the service provider. Instagram, the company, keeps your photos on S3 and handles all that for you, and it's not a question of whether or not your photo will be kept, forever. It's baked into the model, and so one of the problems we have here is, well, that creates a cost for Instagram, and does that cost? How do they turn that into a sustainable business? And the classic answer in Web 2 is advertising, right? For us, in particular, we had a really interesting intersection with the data availability problem, in that my initial understanding of the problem of like, why does a GitHub for data not exist, really stemmed from, if you look at data versus code never really gets that big. And so it's really easy to build something like GitHub where you can say, hey, just give us all of your code. So really robust and easy solution to both private and public code hosting. And a category of problem where like you're never really hosting more than like a couple 100 megabytes of like any user's data. And so you get to have this free for all, everybody come on, join, give us everything, give us all your code, because the costs don't scale with the user growth, with the growth of the user base. With something like data set cataloging and management, every user that you bring in and you say, hey, come and bring all of your data, you'll notice that all of the other services in data cataloging generally put some sort of cap and say like, the biggest data set we'll take is often 500 megabytes, or like, certain things that are based on the calculus of how many users could we onboard, because our costs scale as more users join us. For us, we were hoping to use IPFS to solve this problem, right? Again, if we could achieve hockey stick-like adoption of a peer-to-peer based network, we can actually offload the cost of the data availability problem onto the network itself and have the users self-propagate that. And so that would allow us to say, cool, we as service providers can just be in charge of being that last line of defense of having just like keeping one copy everywhere. But then the actual like fetching of the data would be really a lot more, in a much more day-to-day context, would be baked into the network itself. That was the hope. That would be the way that we would decouple the cost of scaling from the actual business itself. Our approach was, for better or for worse, really not into blockchains. We didn't want to sort of bring a direct and specific incentive layer into our technology. We'd sort of thought about it a lot more like Git, and thought it should just be a thing that is, you can use it independent of any sort of monetary scheme. that, and that's a double-edged sword, right? Because we then lose a little bit of the like hype you can get around like actually building. We could have really easily gotten into, hey, I'm making this data available and you have to pay for it, because if there's a payments mechanism built right into it, then you can actually do pay to access type stuff a lot easier. But then you also get the advantage of a lot of people hear the word blockchain and are like, nope, that's not a tool I want to use. And so we did also get to talk to that type of user base. Go ahead,
sorry to interrupt, Brandon, but could I ask, let's say a bit of a critical question to make it a bit lively, more lively. It's already super interesting. But if a lot of your customers have this requirement of data needs to be private, isn't that almost a sign that, potentially that you have no business being decentralized if data is actually private? I mean, either you want private data to be safe and secure, and then we've established that the simplest and probably most efficient model for that is that you find someone willing to guarantee a service level just in the old Web 2 paradigm, and then you do that. Or your data is open and used by many, such as in the case of the internet, let's say JavaScript code that everyone uses, or a lot of things that we could potentially save on that per the original IPFS vision. And then there should be a case, and there should be a market, certainly with scientists, for instance, for open data sets. But to do both, decentralized and private, isn't that a little bit like trying to find a market that doesn't exist?
Oh, you hit the nail on the head. Where were you 4 years ago? Because this I think was one of the biggest lessons that I sort of alluded to with the question of like coming at this and not being somebody who was a data practitioner, like bred in the bone type thing. I think your question really gets to the meat of it, which is the way that data is valuable is fundamentally different from the way that code is valuable. And I came to learn this lesson the hard way. In that, the exciting thing about code is the zero cost copying and the zero cost execution. If I write a piece of software, I can give you that software and it has very little effect on me, right? If you're running the same software as me, the fact that the code is executing and doing something for you, it may do a slightly different thing for you than it will for me because it's a program and it can sort of react to input and change its outputs. The value of data is what it proves. And for a lot of folks, you build up and defend that knowledge into a business asset. And that's one of the key drivers of data being private, is you actually want to protect who gets the knowledge that the data can give you. And the value of that knowledge actually diminishes as more people have it. If you make a data set open, as an example, if we had a company say that did a whole bunch of user research and actually determined that if the button is green, then it is more people will click it than if the button is red, then and they have like a factual basis for that, and everybody on the internet changes their buttons to green, then the value of the green button goes down, right? Like there's a relationship between how the value transfer process happens with data that is distinct from the way that code works. And so exactly to your point, in a lot of ways, Qri was chasing a market that maybe didn't exist, because we had a lot of users asking us for private data. And as you said, marketplaces around that. And like, as you said, there are robust solutions to that in the Web 2 space. And that architecture actually is much more solved. And then on the other side, we have the open data side of things, where folks just want to disseminate knowledge for the virtuous sake of disseminating knowledge and understanding that like this like hoarding of value is kind of a characteristic that doesn't need to be universal. And that for us was really like, I always wanted to work on the open data side of things. I genuinely wanted to facilitate the construction of the data commons. I thought that, I really wanted to see a place that everyone could start to get to that zero cost copying on the data side of things. If we look in like, as an example, like the machine learning space, there's really only 5 data sets that everybody uses to like start to understand their training models and like get their head into data science. And like all the really like juicy stuff is like you go get a job at a company, and that's when you get to like touch the real data and build the real models. It's kind of sad. Like, wouldn't it be awesome if that like 5 data sets turned into like 25, 35, 1,000? Like, why aren't we trying to sort of build that as a group? And the challenge is like,
depends a little bit, just as a note, depends a little bit on the domain. Some scientific domains, like physics, for instance, there's tons of open data.
Yes, and genomics, and we came into encounter a lot of and like the measurement of latency on the internet. Like we found a number of really great use cases where folks have really big data sets, and measurement of volatile organic compounds in the atmosphere. Like, just to get back to the EPA, like we definitely saw a lot of these. The thing that is so interesting about that space is so many about the public side. Two things I want to say that. First, the advantage of GitHub is gone out the door, right? Because with GitHub, they got to say, give us all of your code, all of your data, private or public, we don't care. And that top of mind, it's one-stop shop for all of my version code maintenance and cataloging needs it's a really important characteristic to know that you can use the tool both in public and private context. The second thing is that on the public side, the solutions tend to break down by sector. People that are working in neurological imaging and trying to disseminate open data sets of neurological imaging have a completely different mechanism than the people doing GTFS or like transit data syncing. Like, they end up with different schemes, and they all end up being custom-baked solutions to their industry that they all tend to build, stand up, and share amongst each other. And designing a generic solution for an open data cataloging system to solve something that would both accommodate the geneticists, the atmospheric analysis, and like the transit data analysts becomes really difficult, because it's really hard to argue with every incumbent tool. We tried, but this is where we come back to the cost of iteration. If you can iterate really fast, aka if you're centralized, you stand a better chance of actually robustly answering that question. But for us, it's like you have to sort of pick your battles, and we picked a lot of battles. I hope that helps contextualize. I want to try and answer some more questions in the chat, but does that sound good, Rick? Thank you. These are really cogent questions. I really appreciate it. Coming back to chat, are there particular features or business choices that ultimately wound up feeling like false paths, even if they seem like great ideas at first? Yeah. The list feels so long, it's hard to pull apart individual answers. One of my favorite ones was like one of the early applications of Qri that we thought would be really exciting to chase down was really big companies end up establishing lots and lots of departments that end up recreating the same data sets over and over and over. And we thought that utilizing content addressing would allow us to create a self-discovery mechanism where different departments of really big companies could find each other's reconstruction of data sets. We never got to meaningfully test that theory, but it seemed like a great idea at first. And one of the challenges we ran into, actually, this is much more on the business construction side, is like the realization that if we were going to actually make any inroads in the corporate space, we would have needed to spun up a sales team to actually really help us establish relationships inside the business world. And that when you're working at a startup with a finite set of resources, it becomes really difficult to get the team in place to test a divergent theory like that. So it seemed like a great idea at first. We started some conversations with some really big companies and realized that on our side, we actually couldn't even keep up with the requests to properly sort of keep that conversation moving. And we couldn't deal with their timescales, where like it would have taken like a year to test that theory. And we didn't have that year to find out whether it was going to work or not. And then the follow-up question to this is, and conversely, what things actually really were the smart choices that panned out over the course of the project? The thing that we think I think the big one that jumps out to me was the realization over time that like the binding data to code thing for us became a really, really exciting thing over time that I still think represents a lot of unexplored potential. it was baked into Qri from the get-go, but like we ended up doubling and tripling down on it the longer that we went, because we just came to realize that code and data are different things, and that most people actually write code to maintain data. That's the arrangement that like worked the best for like the truly organized in the world. And so Qri at the end, at its current state, is actually a tool for maintaining the code that builds the data and packaging those things together so that they can't be separated. And for me, that really worked. I think there's a ton of potential there. And I would like to see that explored more. Timothy asks, your initial intention to provide governments with a better data repository, did you get the adoption acceptance you expected with that audience, with the government audience? Did they have unique concerns? Were they interested in supporting the program? We intentionally didn't target actual governments. We had some conversations with city level governance. The reason we didn't target them is we always knew, again, this comes back to sales cycle. It was a minimum 2.5-year procurement process for most of these organizations. And so we got into some conversations with some state level government, some city level government, but we didn't chase them super hard. And we basically said, cool, if you're willing to come to us, great. We're going to just continue growing this tool out and hope that we can really target folks who understand the value of open data. And that was really where we chose to focus our time. So there was interest in supporting the program. And I did not find their concerns particularly unique. I think their processes are unique, but their concerns didn't seem to be. Hopefully that answers the question too. Cool. Christian, can you elaborate more on what you mean by tying code to data and an example of what you mean by doubling down on it? Yes, absolutely. So inside of Qri, we had a very specific definition of data set, which is broken into components. So we put the user-facing metadata in one section, called it meta. We put all the machine structural metadata in another component, called it structure. And then we added a component called transform, which contained the actual script to construct a data set. And we bound them together by putting that all in the same IPFS DAG. So you always got, when you downloaded a version of a data set, you actually got all the metadata, all the structure, the README, and in particular, the transform script that was attached to it. And if you wanted to, you could re-execute it. And we ended up deciding on, we realized the implications of that, which was we're now shipping code around that people are going to execute. So we built a pretty intense sandbox around it. But that's what we mean by tying code to data. And what we mean by doubling down on it is actually doubling down on the construction of that sandbox and of thinking about how do we expand that universe of functionality inside of that scripting environment so that it can be big enough to be sort of useful in the data science space. And so for us, that meant writing an implementation of data frames inside of a language called Starlark, which ideally would make data scientists happy because data frames are a really common primitive in the data science space. And so we actually rolled up our sleeves and wrote the majority of a thing that was written in Go that would interpret Python syntax and actually execute to make it look like a data frame, even though it wasn't Python. And it was a whole thing. And it's a project I'm still excited about if you want to hear more about data frames in Starlark. But
yeah, totally gonna message you all like after this about that stuff. Thanks.
Yeah, and we have lots. And I think honestly, like the question that I haven't been asked, but would totally plug at this moment is like there are lots of parts of Qri that are already independent and reusable libraries. Our JSON schema library is used at a number of big companies that I'll leave unnamed so that they don't, I don't know, get mad at us. But JSON schema get used a lot. And this Starlark stuff. So Starlark is a language that was originally part of Google's Bazel build system. The syntax is exactly like Python, but the upside is it's actually Turing incomplete. So there are no while loops, there's no recursion, which means it makes it a really predictable language to execute. You can actually statically analyze a Starlark program and determine the maximum number of steps it would take to complete, which is a very interesting property to have in a language that looks a lot like a familiar coding syntax like Python. And so we ended up shipping a lot of what are now the core modules in the Go implementation up into the Starlark repository itself. And it's a growing ecosystem. There are, I know that Facebook's getting involved. I know that, Meta is getting involved. Google obviously kicked the project off. There's a number of other companies involved in Starlark. And so I think it represents some unrealized potential. We maintain a repo called Starlib that includes a whole bunch of experimental packages that you can use with it. InfluxDB, they use Starlark for Python programming of their database layer, query layer. I know they use it. We get InfluxDB users showing up in our Discord. But yeah, so there's parts of query that are just like fundamentally useful in my humble opinion. And like we've separated, there are like 100 repos on the query org, some of which will be finding new homes over time. Some of which are not good to use, some of which are very good to use. So if you have questions about that, I'll be in the Discord, the query Discord for months to come, and happy to talk about which bits might be useful for others' projects.
Awesome, thank you.
No worries. Thank you for letting me answer a question you didn't ask. Anybody have any other questions? I totally didn't think this was going to work. It's just like a Zoom call, but this is a lot easier than frantically typing into Reddit, I have to say.
Hello.
Is that it? Hello.
Yeah, sorry I joined late.
all good.
Yeah, recently discovered Qri. So I'm also a Golang developer. So I saw it and I saw it was a very good it's a very good idea. And I started exploring. But when I was exploring, that was when I discovered that the project is closing down. So curious enough, I joined the Discord to know why, because it was something I was thinking of picking up and probably contributing to it. So I want to ask, are you still considering not closing it down, or it has been finalized already? And what will be the steps that will be taken afterwards? Like, will the repository still be maintained by you, or so? I'd like to know
Or others.
about
Yeah,
that.
like what the future plan for the project is.
Yeah.
Thank you.
yeah.
It's a great question. So as it stands right now, the company behind the project is spinning down, and that is a final decision. We're not. It's kind of a one-way street on that. You have to when you announce to your team that you're splitting down, they all get to decide how to move on with their lives, and so we do owe that to them. But as for maintaining a community-driven project, I am definitely still pretty passionate about what we were trying to accomplish at Qri, and am really open to a community effort, and like including bringing on new maintainers or figuring out how to set up the project for success. With that said, I don't think it would be a good idea to just say, hey, the community is going to keep building this thing that had a whole company behind it, and like just keep the mission the same and the like approach the same. And so what I've been focusing on in conversations with a number of folks who are interested in a community driven model is understanding what they'd like to do, what they would really like to see happen, or what drew them to the conversation in the first place, and seeing if we can cut pieces of Qri out to facilitate that happening. I think just asking folks to like straight up maintain the existing Qri, the main Qri repository, would be a really tall ask. It's a very, very, very complicated tech stack. And so I'm trying to work with a number of folks to identify, hey, what are the common pieces that we all really want to see continue to exist? And if the answer is just existing Qri, then I'm sad to say that we probably don't have the resources at hand to do that. But if it's some subset of that, like, hey, we really liked your naming system, or we really understood you're working on this encrypted data thing, that sounds really useful. Qri has some access control layers built into it. That sounds really useful. Some data synchronization protocols. That's really useful. We want those things. I think those are the things that are really ripe to be moved into a community maintenance mode, because A, that's something that really fits inside of a schedule that I can maintain and help be a participant in. And B, I think it helps scope the project down and generalize the applicability of the technology. And so I would love to use our Discord to talk about that. And I will post after this conversation that if others have parts of Qri that would be useful for their work, that we should talk about figuring out how do we establish a roadmap for community maintenance of those things. But I will be very upfront and very direct about whether or not I think that is feasible long-term and whether or not we can commit resources to doing that. It drives me nuts when people in the open source community say, oh yeah, we can totally do this. And they don't actually have the time blocked off in their calendar to move that forward. And so I have no interest in making empty promises on that frontier. But if we have enough people who are interested in the thing and we can properly divide up the work and really scope the work properly, I think I would love to see any part of this project continue. Hopefully that answers your question.
Yeah, it does. You think?
Great to hear, Quality. I'd be happy to follow up on Discord if you have any other, if you want to get specific.
Yeah, I think there's also should be some opportunities in like European communities and also European funding. I mean, if anyone in Europe wants to do this, it's a world that I came from, so I know it quite well. But European Commission has quite a number of grant programs, which are really focused on things like this. It's also trying to, I call it European sovereignty in terms of not being dependent on Google and Meta and companies like that so much, and owning the internet. But in that space, there's a lot of funding for especially European companies that want to maintain this. So the least I also can do is try and socialize this a little bit in my network and see who's interested there. Ultimately, of course, you need a dedicated team if you really want to keep a service online. And unless all of the websites and the services were so good that,
If they just kind of run themselves.
Runs itself, but that clearly nothing runs itself.
No.
And maybe Ethereum runs itself. Maybe you could make the argument that just plug in another Ethereum node. But if the Ethereum development team would stop, tomorrow, it may still work, but a year from now, it's also going to die. So you need clearly you need a team to drive it.
Yeah, and that'd be super exciting. I mean, I think that Qri is pretty self-maintainable. It's not a big surface area. Even Qri Cloud, which may seem complex, is not actually that complicated. In contrast to a lot of other services, part of that derives from the fact that it's a single binary at the end of the day, and so like almost all of it's sort of contained inside of this one thing. And for the use cases, we obviously haven't been able to test Qri at massive scale. So like doing all of Europe's data sovereignty, I can't answer that question meaningfully, but exploring that problem would be super interesting. And so if you have any interest, Reese, I'd be again delighted to chat on Discord or whatever you feel is the most comfortable forum for those conversations. Cool. I want to make sure that I answer these two questions from Christian. Can you touch on the different solutions for indexing you looked into and any site insights you gained from your research? Yes. The initial version of Qri had LevelDB built into it, and it built an indexing node and facilitated local node search. It was super cool. I liked it. I don't know why we took it out. Oh, right. We took it out because, again, just performance. Multiple databases running under the hood. Just as a general piece of advice, pick one database, use it for all your stuff. It's a great way to make sure that you don't need a lot of memory. The indexing on decentralized data is a very interesting problem. So the way that we do search now is we wire up Elasticsearch to everything that gets posted to Qri.cloud. And the biggest thing that we do that makes that more useful is the dataset model includes a mechanism for summarizing itself. And so we have a definition of a dataset summary. There's a bounded set of bytes that is effectively primed for previewing and indexing. And commingling those two concepts and building that into our spec made indexing a much easier affair. And so that process of generating dataset previews, we call them, is actually a node local process. So any node can generate a preview of any dataset, and in the later iterations, it didn't even need to have all of the data to be able to do that. And that, I think, was a really great technique that I would personally recommend across anybody who's doing anything. If your data exceeds, if the fundamental unit of your system exceeds a megabyte, I think you would benefit from a summarization technique that takes that thing and just boils it down to its essence, prepares it for both previewing and indexing. I think you'll have a better time. And particularly if you can have that process be deterministic, and then you can have that, you can execute that across anywhere on any node. I think that's the biggest thing we learned about search and how to do search right, because it would have been really trivial for us to hook up local search after solving some of the performance constraints. But that technique of saying, hey, given any X, can you make a minified version of X that just represents, that takes out a lot of the data, but represents the stuff that would be really good to put into a search index? I think that's a really great technique.
Thank you for that. Thank you so much. This has been great.
Of course. Question from Cole saying, Brendan, Casey team, were there many topics that were adjacent to your work on Qri, but you weren't able to pursue until now? Anything interesting on the horizon for you all? Great question. Casey's in the call, so maybe Casey can answer that. Casey, do you want to take it or do you want me to?
Also, I just want to say hi, Cole. And hi, Rob. Sorry to everyone else that I'm not saying hello to you, but those people I actually know. So I just want to say this thing because I think Cole will think it's fun. Cole, I'm learning Rust. That's my, now that I've been unmoored from the shackles of Go, I now have the freedom to learn Rust. So that's actually the thing that I've been kind of looking at as an exciting project for me. That's
awesome.
why I answered that right now.
Yeah. The last company that I was just at has been all Rust for 2 years now. And then the next company that I'm moving to is all Rust as well. So I'm all there.
I'd answer the same way, learning Rust. I'm also finally getting a chance to dig in more on formal verification techniques. So I'm spending a bunch of time with TLA plus as my latest thing. And I think this is like a general tip for people working in Web3 or decentralized systems. We're having a lot of trouble with decentralized systems in measuring emergent properties, understanding how these distributed things work when you have lots and lots of nodes. And this world of academia has a lot to offer us that I think is under considered in the day-to-day practice of a Web3 engineer. And so I think that actually taking the time to get up to speed on some of the literature of, in particular, impossibility proofs around distributed systems is really, really useful. Knowing what you can and can't do is super useful. But then TLA gives you this, like, and other models like other executable specs give you these really exciting chances to like actually have a system go and tell you all the possible states of your distributed algorithm and how to understand what some of those emergent properties will look like before you even write code. So for me, that's the adjacent thing to my work on Qri that I'm now able to pursue because I finally have some time to like slow down and formalize things. So that's my answer. I don't know if that helps.
I have another sort of kind of tangentially related, sort of nebulous answer / question that something I've been thinking about, which is I've been very fortunate in my work in Qri to be working on something that uses the Web3 space in a way that doesn't offend my moral sensibilities, I guess I should say. And now that I am outside of that, I want to continue working on things that I find interesting and that I find challenging. And I think there's so much of that in like distributed technology. But now I'm trying to develop a stronger, better opinion about like why those things should exist. Should they exist? When they exist, when and if they exist, who do they serve? How do we get well, if we want to be serving people who are currently underserved, that means that things have to be accessible in a way that they just aren't right now. Why should people want to join us on this trip? What are the actual benefits and things that we can point to say, hey, no, you do want to do this because you do want to put in this extra effort to be on this distributed system because we can give you these reasons. And now that we've have a tiny bit, I would say like, we have a tiny bit of history in understanding and people attempting to create application, like distributed applications and create some of these technologies. We do have some things to pull off of to go like, hey, is there evidence that anyone would want to use any of this the way that it currently is? And try to like think critically about what we've learned and how we can keep moving forward. I just like, we're just in the infancy of all of this. And I don't think there's going to be a good answer for another decade. But like, I want to, another personal project is to learn more about these things so I can have a better, stronger opinion.
I think that's a perfect place to end. We're going to pass the hour. I love it. Thank you so much, everybody.
Casey. And I think that finding a forum where we can discuss that, like adjacent to Moon Boys, let's say, that would be great. And there must be a lot of interest in that. So let's find a forum for that and continue this conversation somehow.
Absolutely. And why don't we use the Qri Discord to find that forum? We don't have to end the Qri Discord, but let's use that so we can signpost where folks are going, because there's a distinct lack of Moon Boys in that Discord, and we can figure out where to go from there. Thank you, everybody, for your time. This is really, really appreciated. If you have any other questions, I'm again going to direct you to the Discord, but feel free. I'm going to be around there, not leaving anytime soon. Thank you so much, everybody.
You.
Thank you.
Thank you. Bye.